In this video, the learner will rotate a figure on the coordinate plane and find the algebraic rule for each rotation. A rotation is a function that maps a figure onto another by rotating the figure around a fixed point called the center of rotation with a given angle x. So in this figure here, our center of rotation is point C. So every point is going to get rotated around that point. That is our center. Now, we have a couple of things that we need to consider. If the point that we're trying to create the image of is the center of rotation, then the pre-image and image are in the same location. So if we're trying to rotate C around itself, it's going to be in the same exact spot. It's not going to move. So if a point is our center, then it's going to stay in the same spot. The second is if the point isn't the center of the rotation, so if we're talking about another point other than C, then the pre-image and image are the same distance from that center. In other words, we can say that this is a center, and each of these distances would be radii of the circle created if we were to draw that through center C and each of those points A and A prime. So we have that circle that would go through both of those points. We have two types of rotations, clockwise and counterclockwise. We determine the amount of the rotation based on the amount of degrees that we're going to turn. So our four basic rotations are going to be 90 degrees, 180, 270, and 360. 90 is 1/4 of a turn, 180 is half of a turn, 270 is 3/4 of a turn, and 360 is one whole turn. So if we were to rotate this letter A, 90 degrees would be 1/4 turn. Turning upside down would be a half turn. Turning 90 more degrees would be 270. And then turning back to our original position would be one whole rotation. So what we want to do here is we want to describe each rotation that happened. So if I were to describe this rotation, I could go clockwise, 90 degrees. So that would be considered a 90-degree clockwise rotation. Here for the letter P, rotating clockwise, it would be 90 degrees here. Notice it does not look the same as our ending figure, as our image. So go 90 more, we have 180. Still not the same. And here we are at 270 degrees. So at 270 degrees clockwise, we create that image. Okay, lastly, we have this triangle we're going to rotate. 90 degrees clockwise, still not like our image. 90 more degrees, and we've created that image. So that would be 180 degrees clockwise. I want you guys to answer this question. Could you represent those angles differently? So could you describe these rotations in a different way? Now we're going to actually rotate a figure on the coordinate plane. We're going to draw the resulting triangles when the triangle is rotated 90, 180, and 270 degrees clockwise around the origin. Now when you're doing this at home, you'll be doing this on graph paper, and what you're going to do is physically rotate your paper 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees to our original position. So to rotate this 90 degrees, I'm actually going to take my figure and rotate it 90 degrees. And then I'll realize that I have this blue triangle. This blue triangle is going to be my 90-degree rotation. Notice now I can count the points as if they were my original points. So A is now at positive 9, 3. B is now at 7, 7. And C is now at 2, 4. Okay, I'm going to return to the original position. Now I'm going to rotate this 180 degrees. When I rotate this 180 degrees, I'm going to basically turn it upside down. And I'm going to end on this red triangle here. So I'm going to rotate 90, and I still end on the blue triangle, 90 more degrees, and I end on this red triangle, where A prime is now at 3, -9, B is at 7, -7, and C is at +4, -2. All right, I'm going to return to my original position and rotate 270 degrees clockwise. And I'm going to end on this green triangle here. 90 degrees, 180 degrees, and 270 degrees. So now I'm going to look and see these points, -2, -4, -9, -3, and -7, -7. And those are the image points for my 270 degree rotation. Now notice if I were to go 90 more degrees, that's one full rotation, and I'm back in my original position. So 0 and 360 degrees will actually be the same rotation. Now I want you to consider each of these rotations and describe what happens to the coordinates in each of these and come up with a rule for the 90 degree, 180 degree, and 270 degree rotation clockwise. In this problem, we're now drawing the resulting triangles when the triangle is rotated 90 degrees, 180 degrees, 270 degrees, counterclockwise around the origin. So now we're going to be taking this triangle A, B, C and rotating counterclockwise. Using the same method that we did before, you're going to physically rotate this figure, and now point A would be at -1, +3, B would be at -6, 0, C would be at -8, 4, and then record those image points. I want you to do that for all three of those and describe what happens to each of the points and come up with a rule for 90, 180, and 270, counterclockwise. Lastly, I want to draw the resulting triangles when the triangle is rotated 90, 180, and 270 degrees counterclockwise around the point -1, 2. So this problem here now gives us a new center of rotation that is not the origin. We're going to now treat that point as our origin. And so when we rotate this, we're going to rotate all of this together and pretend that this point -1, 2 is now our origin. I want you guys to try this one and we'll go over this one in class.